In this problem, I need to find the local extrema. I need to find the intervals on which the function is increasing and the intervals on which the function is decreasing. So first I'm going to start off with the domain of my function. And I don't have any logarithms or radical signs, but I do have a denominator with a variable in it. So I know that x squared minus 4 cannot be equal to 0. I know that x squared cannot be equal to 4. So I know that x cannot be equal to plus or minus 2. Those are forbidden. Now, I know that where I have a denominator of 0, my function is either going to have a vertical asymptote or it's going to have a hole in the graph. It has a hole in the graph only when I can cancel out a factor in the numerator and the denominator. So since that is not happening here, I know that my graph is going to have vertical asymptotes here at -2 and at +2. So that's something I want to keep in the back of my head. So let's write the domain in interval notation. It's going to go from -infinity to -2, union -2 to 2, union 2 to infinity. The only 2 points where I can't have any domain in this function are -2 and 2. Well, okay, let's find what the derivative is. F prime of x. Well, I have a quotient here, u and v. I think I'll use my quotient rule, which is uv minus uv over v squared, with the prime going front to back. So u prime is 1 times v, so that would be x squared minus 4, minus u, which is x, v prime times v prime, which is 2x, and all of that is divided by x squared minus 4 squared, v squared. Let's simplify a little bit. So I have equals x squared minus 4 minus 2x squared over x squared minus 4 squared. That looks like it equals negative x squared minus 4 divided by x squared minus 4 squared. There is nothing else I can do to simplify this. I know it looks like it should be simplifiable, but this negative sign right here in front of the x squared makes it so that I wouldn't have the same sign to be able to cancel out an x squared minus 4. So let's see if I have any critical points. Do I have any points where f prime of x, which is negative x squared minus 4 divided by x squared minus 4 squared, is there any place where that equals 0? Well, I'm going to concentrate on my numerator here. Negative x squared minus 4 equals 0. Negative x squared equals 4. X squared equals negative 4. Now, there is no x where I could have it squared and have it equal to negative 4. So there is no place where f prime of x, it never equals 0. Okay. So I don't have any stationary points. Now, do I have any other critical points where f prime of x do not exist or may not exist? Well, I can look at the function f prime of x, and well, I have a denominator here, and I know that the domain of this f prime of x, well, the denominator is going to be, it's going to give me the same domain as the function overall, which is -infinity to -2, union -2, 2, union 2, infinity. I could find that. I mean, I'll just work it out real quick for you here. But I mean, if I set x squared minus 4 squared equal to 0, I would take the square root of both sides, and I would get x squared minus 4 equals 0. And that's exactly what I was working with way up there with the function to find the domain. So I know that the domain of the derivative and the domain of the function are the same, so that's telling me that f prime of x does not exist where x equals -2 or x equals 2. But that's not a critical point. That's not going to become a critical point because x at -2 and x at +2 are not even part of the function. So they don't exist in the function, then they certainly can't be critical points. So while I have no critical points, what I do know is that I have a graph, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I know that at -2 and at +2, I have vertical asymptotes. So it wouldn't hurt me to test each interval of this graph. Well, whatever value I have for x, I can see pretty clearly that my denominator here is going to be positive. Because whether I get a positive number or a negative number inside this parentheses, I'm squaring it, which means it's going to be a positive number. So really what I'm concerned about is whether the point that I choose is going to make my numerator positive or negative. So let's choose the point -3. So let's find -3 squared minus 4. Well, that gives me -9 minus 4. That tells me that that's a negative number, so in this interval here, it's going to be negative. What about at 0? -0 squared minus 4. Well, clearly that's also going to be negative. And what about at +3? Well, +3 squared minus 4. Again, that's going to give me the same answer as -3. So that's going to be negative. So all three of these intervals are going to have a negative slope. So how I would write the answer to this question is no critical points. And I would say the function is decreasing over the entire domain, -infinity to -2, union, -2 to 2, union 2 to infinity. And the function is not increasing anywhere. Here's the graph on the Desmos calculator, and as we can see, negative slope, negative slope, negative slope, really negative slope, more negative slope, negative slope, negative slope, kind of leveling out a little bit, but it never gets even to 0. Negative slope, negative slope, negative slope, negative slope, negative slope, negative slope, negative slope. All three intervals have negative slope, just as we predicted.